Today, I want to talk about how we can use the limit definition of a derivative to calculate the derivative of the function. So first of all, what is the limit definition of the derivative? Well, it's the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So let's use that formula to calculate the derivative for these three functions. So here we have our first function, which is f of x equals 4 minus x squared. So we're going to take the limit as h approaches 0 of, and then f of x plus h. So wherever we see x, we're going to replace that with x plus h. So we get 4 minus x plus h squared. And then we're going to have minus f of x, so minus 4 minus x squared. Then divide that by h. So then we can say this equals the limit as h approaches 0 of, and we're going to expand this. This will become 4 minus x squared minus 2xh minus h squared minus 4 plus x squared, right? Because this is double negative, so that'll become a positive divided by h. Then we can cancel some things out. We have positive 4 and negative 4, so those can go. And here we have minus x squared and plus x squared, so those can go. So then we're just left with the limit as h approaches 0 of negative 2xh minus h squared divided by h. Then this will equal the limit as h approaches 0 of, well, we can just factor out an h. So we get h, negative 2x minus h divided by h. Those cancel. And we just are left with the limit as h approaches 0 of, actually we don't need that, negative 2x minus h, right? And obviously, as h approaches 0, we can now just plug that in, and we get negative 2x. And that's our derivative, okay? Now let's move on to this function. So I think it'll be more convenient for no, we'll keep it as is. I think it'll be fine like this. So now we want to start with the limit as h approaches 0 of, this will become 1 over x plus h squared minus 1 over x squared and then over h. So now what we're going to start with doing is we're going to multiply both the top and the bottom, right, by x plus h, right, and x plus h squared and x squared, okay? So we'll end up with the limit as h approaches 0 of, this will become h times x squared times x plus h squared, and then this will become x squared minus x plus h squared. So that's what we have now. So now this equals the limit as h approaches 0 of, well, we can expand this on top. We never really want to expand the denominator unless we absolutely have to, okay? So x squared minus, and this will become minus x squared minus 2xh minus h squared. All right, so obviously you can see those cancel out, all right? And then on the bottom we'll have h times x squared times x plus h squared. Then this equals the limit as h approaches 0 of, well, up here we can factor on h. So this will become h negative 2x minus h over h x squared, and then this is x plus h squared, right? So obviously those will cancel out, and we're left with the limit as h approaches 0 of negative 2x minus h times x squared times x plus h squared. Now we can plug in h equals 0, okay? And if we do that, we'll get negative 2x over, and then this will become just x squared. So x squared times x squared is x to the 4th. Now, this can cancel out with this, and this will become 3. So it'll become negative 2 over x cubed. That's not very good. X over x cubed. And that's our derivative. Now let's move over to this one. So the limit as h approaches 0 of, well, we're going to start off with just plugging in x plus h. So we get 2x plus h plus 1 minus, and then f of x, or in our case, h of x, sorry. 2x plus 1. Then divided by h. So this equals the limit as h approaches 0. So now what we're going to do is we're going to use the difference of squares, and we're going to multiply both the top and the bottom by the square root of 2x plus h plus 1 plus the square root of 2x plus 1, okay? We're going to be using difference of squares. So on top, we'll end up with 2x plus 1 plus 1, sorry, that should not be x plus h, then minus 2x minus 1, okay? And then down here we'll have h times the square root of 2x plus h plus 1, okay? Then it'll be plus the square root of 2x plus 1, rather than minus, okay? Now, what we're going to do is we're just going to expand on this, and we're going to see what we get. So it'll equal the limit as h approaches 0 of, this will become 2x plus 2h plus 1 plus 2x minus 1. Now, obviously, we can start to see some things will cancel out, right? Like this minus 2x and this plus 2x will go, this plus 1 and this minus 1 will go, and we're just left with 2h on the top, right? And then down here, we'll have h square root times the square root of 2x plus h plus 1 plus square root 2x plus 1. Now, in the future, if there's something you want to do, right? If you have something long like this and you don't really want to rewrite it, something else you can do is you can say this equals, say, c, and then you can just write c for your denominator if you're going to have to go a few steps without changing your denominator. But in our case, we're not doing that because, as we can see, we're just left with 2h. So the h's can cancel out, okay? Let me get rid of that equals c, right? And now we can just plug in h equals 0 down here. So we're left with 2 over, and this will become this 2 square root of, and then this will become 2x plus 1, right? So then these can go, and we're just left with 1 over the square root of 2x plus 1. And that is our derivative. Thank you for watching. Let me know if I say anything wrong or if you have anything additional to add. Have a great day.